Watching this video, you have decided you want to understand machine learning, and I think that's one of the best decisions you can make right now. I am Ahmed Sahmi, and this channel is about teaching ML and AI from the beginning. No fluff, no unnecessary jargon, just clear explanations, real examples, and hands on code. This is episode 1, module 1, the foundation of everything you will build together. By the end of this video, you are going to understand what machine learning actually is, how it's different from the programming you might already know, and why right now is genuinely the best time to get into this field. Let's get started. Here's a quick look at what we will cover today. Four things: what ML actually is, how it differs from traditional programming, where it's already showing up in your daily life, and why this is the right moment to learn it. Simple structure. Let's move to next slide. The big question. Let me start with the question. How do you teach a computer to learn? Think about that for a second. When you write a program, say a function that adds two numbers, you are giving the computer a precise set of instructions. Step 1, do this. Step 2, do that. The computer follows your rules exactly. So, but if the problem is too complex for you to write the rules, what if the rules themselves are not obvious? That's a problem machine learning was built to solve. And that single question, how do you teach a computer to learn, is what this entire field is about. Let's make this concrete because this is the most important concept in the entire course, the key difference. Traditional algorithm was machine learning. In traditional programming, you have data, you write the rules as code, and the computer gives you answers. You are the one doing the thinking. You are telling the computer every single steps what it was to follow. Think about the spam filter built all the old way. You have write rules like if the email contains the word lottery, mark it as spam. Or if the sender is unknown and the subject is all caps, mark it as spam. You are manually encoding every conditions you can think of. The problem spammers adapt. So they change their wording. Your handwritten rules cannot be kept up. So now look at the right side of this slide, machine learning. The inputs are the same. You still give it data, but instead of writing the rules yourself, you give it the answers. You saw a thousands of examples of spam mails and thousands of examples of legitimate mails, and the model figures out the rules on its own way. That's the fundamental shift. In machine learning, the computer learns the pattern. You don't write the rules, you provide the examples, and the algorithm does the rest of the things. This is not a small difference. This changes everything about how we solve problems with software. So, here's what I want you to realize. You interact with machine learning dozens of times every single day. When Spotify puts together your Discover weekly playlist, that's ML. It has learned your listening patterns and predicts what you will enjoy next. When an email goes straight to your spam folder without you doing anything, that's a machine learning model that learned what spam looks like from millions of examples. When you talk to Siri or Alexa, your voice is being converted to text in real time by a neural network. As well as when your phone unlocks by recognizing your face, a model learned the geometry of your face from the photos it was trained on. Amazon's people who bought this also bought a recommendation. That's a recommendation system, as well as the self-driving car perception systems, the fraud detection that flags suspicious transaction on your credit card before you even notice. All of it is machine learning. The reason I am telling you this is not to impress you, it's to make a point. This technology is not futuristic, it's already the backbone of the software world, and learning it means learning how that backbone works. So let's start. Let me give you a formal definition, one worth writing down. Arthur Samuel, one of the pioneers of AI, defined machine learning back in 1959 as the field of study that gives computers the ability to learn without being explicitly programmed. The field of study that gives computers the ability to learn without being explicitly programmed. That process, without being explicitly programmed, is doing a lot of work. Traditional programming is explicitly programmed. Every rules is stated, every condition is coded, and machine learning is the opposite of this traditional programming. You provide examples, and the system finds the pattern itself. The rules emerge from the data. That's the still clearer definition we have. More than 60 years later, keep it in mind. So nowadays, are you thinking about this? So why is everyone talking about this now? ML has existed for decades. What changed? Four things converged to make this era of machine learning. First, the tools have never been easier to use. Libraries like PyTorch, Scikit-learn, which you will be using in this series future, abstract away enormous amounts of complexity. Things that required a PhD and months of implementation 10 years ago now take few lines of Python code. Second, data is everywhere. ML models learn from data, and the internet has produced more data in the last few years than in all of human history before it. That's the fuel for these machine learning models. The third one is the demand for machine learning skills in massive. We are talking about some of the highest paid and most in demand roles in the global job market right now. Companies in every sector are actively hiring engineers who understand this machine learning. The fourth, but this is the big one. AI is reshaping the industry, every industry, healthcare, finance, agriculture, education, legal, and engineering, and etc. There's no sector untouched. The question is not where the ML will affect your field, it's when and how deeply. All four those factors are true right now. That's why this is the right time to learn. What's coming? Here's where we go from here in this module. Next episode, episode 2, we'll cover the types of machine learning, that's supervised, unsupervised, and reinforcement learning. Each solves a different type of problem, and you need to know which is which. The episode 3 walks through the full ML pipeline, the end-to-end journey from raw data to a working prediction of that model. And the episode 4 is where we get hands-on setting up your Python environments so you are ready to write actual code. Every theory episode in this series is paired with the code episode. You will never go more than 2 videos without writing something real. So that's all this introductory video. One sentence to take away from today, what is machine learning? Machine learning is how we teach computers to using example, not the rules. That's it. Everything else in this course, neural networks, gradient descent, transformers, rec pipelines, all of it builds on that idea. If you found this useful, hit subscribe. You don't miss the next episode. Drop a comment below with any questions. I read everyone's comments. And if you are watching this video with someone who wants to learn ML, share it with them. Thank you all.